Hi everyone, how's it going? Welcome back to another video in our digital systems series where I share content related to this topic. If you're in college or taking a technical course in this area and you find some concepts hard to understand, I believe these videos are made for you. In my lessons, I always try to be as clear and visual as possible, showing how digital systems work, using motion and illustration to make everything easier to understand. This method really helped me when I studied this subject. And that's exactly why I'm doing this now, to help students who are going through the same difficulties I once had. So, in this video, we'll discuss the main ways to represent logic functions. Okay, so what exactly are logic functions? We can define a logic function as an operation or device that processes one or more input signals and generates a single output signal. For example, a logic gate, like the ones we studied before, takes two inputs, performs a logic operation, and produces an output. The AND gate performs a series switching function, while the OR gate performs a parallel switching function. In short, each logic gate performs a specific logic function. Alright guys, there are several ways to represent logic functions. Let's take a look at the main ones. Boolean expression, truth table, timing diagram, text description, logic diagram or logic circuit, and integrated circuit, also called IC. Alright, in the past, logic functions could also be described using text form, but that method is no longer used today. So the first way to represent logic function that we'll see here is the Boolean expression. It works similarly to a mathematical expression, as it establishes a relationship between the inputs and the output of a digital system. When we assign input variable a Boolean value that is 0 or 1, the logic function becomes dependent on those variables. So far, we've been working with logic gates that have only two inputs. From this point on, we'll start analyzing logic functions with 3, 4, or even more inputs, expanding the concepts to more complex systems. Alright. Another way to represent logic function is through a truth table. But what exactly is a truth table? It's a two-dimensional structure that shows all possible combinations of input logic levels and how each combination affects the output of the function. In the first video of this playlist, we saw that each logic gate has its own truth table. And as mentioned before, we'll now work with logic functions that have more than two inputs. Throughout this playlist, I will show you in a very simple and didactic way how you can build a truth table for functions with 3, 4, or even more inputs. The next way is the timing diagram is a graphical way to represent how logic signals change over time. It shows a single time axis and transitions between logic levels, zeros and ones, for both inputs and the output of a digital circuit. That's why the timing diagram is such an important tool. It helps us to understand the dynamic behavior of a logic function, unlike the truth table, which only shows the static combinations of the inputs and outputs. So, the logic diagram. The logic diagram, also known as logic circuit, is a graphical representation that shows how logic gates are interconnected within a digital system. Each symbol in a diagram represents a specific logic gate, such as AND, OR, NOT, NAND, NOR, XOR, or XNOR. And the lines connecting them illustrate how signals flow from the inputs to the output. This way, the logic circuit allows us to visualize a physical implementation of a logic function. That is, how it is actually built using real gauge and connections. Alright guys, there's a point. Although it's often called a logic diagram, here in our study, we'll avoid using that term. We'll simply call it a logic circuit or a digital circuit, with more accurate and commonly used expressions in digital systems. And finally, the integrated circuit, also known as IC, is a physical representation and implementation of logic functions inside a single electronic component. Inside an IC, there are multiple interconnected logic gates that form one or more complete digital functions. Each pin of the IC has a specific purpose. Some act as inputs, others as outputs, and there are also power pins, usually labeled as VCC, that is positive voltage, and GND, that is ground. These components are essential because they combine several logic gates into a single chip, making a digital circuit smaller, faster, and more efficient. Okay guys, we've reached the end of another video in our digital system series. In this lesson, we explored the main ways to represent logic functions, how they can be expressed through Boolean expressions, truth table, timing diagram, logic circuit, and integrated circuits. These representations are essential for understanding how digital systems operate and how logic gates combine to create more complex circuits. In the next videos, we'll go even further, learning how to simplify Boolean expressions and design digital circuits based on them. If this content helped you, don't forget to like the video, subscribe on the channel, and turn on the notifications bell so you don't miss the next lessons. Thanks for watching. I'll see you in the next video.